Have you ever truly looked up at the night sky, lost in its profound beauty? And in that moment of awe, have you ever paused and wondered why it's so dark? Why isn't it blindingly bright? Especially when you consider the sheer number of stars, the countless suns scattered across the seemingly infinite expanse of the universe? For centuries, this simple yet profound question has inspired, challenged, and perplexed poets, explorers, and scientists alike, driving them to unravel the mysteries of the cosmos. If the universe is truly infinite, stretching out in all directions without end and filled with an endless supply of stars, shouldn't the night sky blaze with an overwhelming, all-encompassing light in every direction we look? Shouldn't it be an unbearable brightness? Imagine, if you will, standing deep within an endless forest. Everywhere you turn, in every direction you gaze, a tree stands tall, effectively blocking your view of anything beyond. Following that logic, shouldn't the sky above us be a solid, unbroken wall of starlight, a continuous blaze of stellar fire? Yet, our actual experience, what we observe with our own eyes, is strikingly the opposite, a deep, velvety black canvas sparsely dotted with the faint, distant glimmer of stars. This perplexing contradiction, this cosmic puzzle, is known as Olbers Paradox, a riddle that challenges our most fundamental assumptions about the nature and behavior of the universe itself. The darkness we perceive in the night sky isn't simply an absence of light, a void where photons fail to reach us. It's a crucial clue, a subtle but significant piece of evidence about the true nature of the cosmos itself. To begin to answer this age-old question, we must dare to look beyond the immediate spectacle of the stars and carefully consider the universe's vast and complex history, its ever-evolving structure, and its ultimate fate. The darkness of the night, therefore, is not an obstacle, but rather a vital piece of evidence, a silent but profound message whispered from the universe itself, hinting at its mysterious origins and its ultimate, unknowable fate. The dark sky, in this context, is not just an empty void, a meaningless expanse of nothingness. It's the essential key, the Rosetta Stone, to unlocking a deeper understanding of the cosmos and our place within it. The puzzle of the dark night sky has roots stretching back centuries. In the 16th century, Thomas Digges imagined an infinite universe filled with stars. Johannes Kepler later argued that if this were true, the sky should be bright, not dark. The question lingered, with thinkers like Halley and de Chasseau calculating that an infinite static universe would mean a blinding sky. But it was Heinrich Wilhelm Olbers, in 1823, who clearly framed the paradox. A static, eternal, infinite universe can't explain the darkness we see. Olbers's work turned a philosophical curiosity into a scientific crisis. Even Edgar Allan Poe in 1848 suggested that the universe's finite age might be the answer. Light from distant stars simply hasn't reached us yet. Sometimes, imagination glimpses truths before science can prove them. Let's break down Olbers' paradox. This is a thought experiment, a cosmic puzzle that questions why the night sky isn't blindingly bright. If the universe is infinite, stretching out in every direction without end, eternal, existing for all time, without beginning or end, and filled uniformly with stars, meaning stars are scattered evenly throughout space, then every line of sight, no matter where you look, should eventually end on a star. Imagine looking through a telescope. Eventually your gaze should meet the surface of a star. The sky should be as bright as the surface of the sun. Every point in the sky should radiate with the same intensity. You might think distant stars are too faint to matter, their light weakened by vast distances. But as you look farther, the number of stars increases, compensating for the dimness of each individual star, perfectly balancing their dimness. The increased number of stars exactly offsets the reduced brightness due to distance. Every shell of space, near or far, adds the same amount of light. Each layer contributes equally to the overall brightness we observe. With infinite shells, the total brightness should be infinite. The cumulative effect of all those stars should create an overwhelmingly bright sky. The night sky should be blinding, not dark. And yet, we see a dark sky sprinkled with stars. This logical dead end haunted astronomers for centuries. It was a persistent and perplexing problem. The paradox forced scientists to question their most basic assumptions about the universe. It challenged the very foundations of their understanding. Why isn't the sky a solid wall of starlight? What are we missing in our understanding of the cosmos? The answer, it turns out, lies in the universe's age and its dynamic nature. The universe is not static, it's expanding and evolving. The darkness is not a flaw in logic, but a clue to a deeper truth. It's a hint that our universe is more complex than we initially imagined. The solution would require a radical shift in our understanding of space and time, a shift that would forever change our perspective on the cosmos. Early scientists tried to solve the paradox by proposing a cosmic veil, vast clouds of dust and gas blocking starlight. It seemed logical. Dust clouds obscure stars in our galaxy, so maybe they darken the whole sky. For a while this idea was popular. Even Olbers supported it. But there's a fatal flaw. Dust that absorbs starlight heats up and eventually glows as brightly as the stars it hides. Over time, the dust would radiate all the energy it absorbed, making the sky just as bright. The paradox returns. Dust can't hide the light forever. This failed solution showed that no simple screen could explain the darkness. The answer had to challenge the very foundations of our understanding. Scientists realized the solution required rethinking the universe itself. The darkness wasn't an illusion. It was a fundamental clue. The real breakthrough would come from questioning the universe's age and structure. The first real solution came from questioning the universe's eternity. What if the universe had a beginning, a finite age? Light travels fast, but not infinitely, so it takes time to reach us. The observable universe is limited by the age of the cosmos, about 13.8 billion years. We can only see objects whose light has had time to arrive. Beyond that, the universe is invisible to us, its light is still on the way. This means the number of stars we can see is finite, not infinite. The line of sight argument breaks down. Many directions lead to darkness, not stars. The darkness is the shadow of the future waiting for distant light to arrive. The finite age of the universe ensures the sky isn't uniformly bright. But this isn't the whole story. Another piece of the puzzle remains. The universe's expansion would prove just as crucial. In the 1920s, Edwin Hubble discovered that galaxies are moving away from us. The universe is expanding. This shattered the idea of a static cosmos. As space expands, light from distant galaxies is stretched, redshifted, into longer, less energetic wavelengths. The farther the light travels, the more it shifts out of the visible spectrum. Even if distant starlight reaches us, it often arrives as invisible infrared or microwave radiation. The expansion of the universe weakens and transforms the light, making the sky appear dark. The combination of a finite age and cosmic expansion solves Olbers' paradox. The night sky is dark because the universe is young and ever-changing. The darkness is a direct result of the universe's dynamic nature. The solution is written in the very fabric of space and time. The finite age and expansion of the universe lead to one of science's greatest discoveries, the cosmic microwave background, or CMB. The Big Bang Theory tells us the universe began in a hot, dense state, filled with light. As the universe expanded and cooled, light was released and began its journey across space. Over billions of years, this light has been redshifted into the microwave range, invisible to our eyes. In 1965, Arno Penzias and Robert Wilson discovered this faint afterglow, the CMB. The CMB is the ultimate proof of the Big Bang and the final answer to Olbers' paradox. The sky is filled with ancient light, but it's so stretched and cooled that we see only darkness. The night sky's blackness is the signature of a universe with a beginning and a history. The darkness is not empty, it's filled with the afterglow of creation. Modern telescopes like James Webb have revealed even more galaxies than we imagined. Does this flood of new light threaten Olbers' paradox? Not at all. The fundamental solutions, finite age and redshift, remain unchanged. More galaxies mean more light, but most of it is shifted beyond what we can see. Early galaxies emitted intense ultraviolet light, but it was absorbed and re-emitted at longer, invisible wavelengths. The darkness is shaped by cosmic history, expansion, transformation, and the journey of light. Each new discovery deepens our understanding, confirming the Big Bang model. The night sky's darkness is a tapestry woven from the universe's past. Every observation adds detail to the story the darkness tells. Have you ever stopped to ponder the darkness of the night sky? It's a question that has intrigued astronomers and philosophers for centuries. So, why is the night sky dark? Because the universe had a beginning, a point from which everything originated, and it is continuously expanding outwards, stretching the very fabric of space-time. Light from the farthest stars, born billions of years ago, simply hasn't had enough time to reach us yet, due to the vast distances involved. And the most distant light, as it travels across the expanding universe, is stretched, its wavelength increasing in a phenomenon known as redshift, effectively shifting it out of the visible spectrum and into invisibility. The darkness, therefore, is not just an absence of light. It's a crucial piece of evidence that proves we don't live in an eternal, static, and unchanging cosmos. This seemingly simple observation, known as Olbers Paradox, led us to a profound revolution in our understanding of the universe. It revealed a dynamic universe, constantly evolving, with a dramatic past, shaped by events like the Big Bang. The darkness is not emptiness. It's not a void devoid of meaning. It's the presence of history, a record etched in the fabric of space-time. It's the signature of creation, the faint echo of the universe's fiery birth. Without it, without the contrast provided by the darkness, we'd never have been able to see the stars in all their glory. Without it, we would have been unable to discover our place in the grand cosmic scheme of things. The darkness is our window, our portal to understanding. It's what allows us to peer into the depths of space, to observe galaxies billions of light years away, and to look back in time, witnessing the universe as it was in its infancy. It's a profound gift, a cosmic canvas upon which the universe paints its masterpiece, revealing the universe's epic story from its earliest moments to its present state. So, next time you look up at the night sky, remember, the blackness is not empty. It's teeming with information. It's the evidence of a beginning, a singular event that set everything in motion. It's the mark of expansion, the ongoing stretching of space that continues to shape the universe. And it's the reason we can see it all, the backdrop against which the stars shine. In that darkness, you're witnessing the solution, a visual answer, to one of humanity's greatest riddles, a question that has puzzled thinkers for generations. You're seeing the true nature of the cosmos, revealed in its most subtle form. A universe with a finite age, a boundary to what we can observe, a magnificent story unfolding across billions of years. The night sky's darkness, that seemingly empty space, is the universe's greatest revelation, a key to unlocking the secrets of existence.